We're live and recording.
Great. Thank you, Brandy. Welcome everyone to day 3 of RVTEC. Some initial input that Brandy gave us. We had 200 registered. We have 136 in Slack, and then we have 75 introduction slides. So that's great participation. So we'll continue today with the questions on Slack. Presenters should be monitoring from previous. So we've seen conversations yesterday afternoon, overnight, going on from presentations on the previous days, and that's been great. Great activity there. That will continue. We don't know how long we're going to keep. So we're interested in the UNOLS office. So Brandy is specifically interested in feedback on Slack as how long should it persist? How do we like it? So let's do that. We also have the annual meeting. The UNOLS annual meeting is still going on. There are 2 sessions next week, and then 1 the following week. Mm-hmm. Yep. Mm-hmm. And 2 other things. So Andrew Wugan volunteered and has been approved by council for the RVTEC rep to the SCORE committee. So that's and then we also have 2 tech training committee slots. So please let the tech training committee know and Brandy know if you have technicians that are interested in participating in the tech training committee. Next thing we should do is we should approve the meeting minutes from last year. So we're still in the introductions channel. Is that what? Yeah. So I'm looking for someone in Slack to for a motion to accept the meeting minutes. Need a motion and a second in the introduction Slack channel for those who have looked at read through the meeting minutes. If I don't get that now, I could do it over the course of the meeting today. But that's what I can send something out on that channel, that Slack channel too. And I hope everybody's thinking about LumCon today with the storm and then going into Cocotree. I hope those folks are doing well. They've had a rough time with the storms this hurricane season.
This is a big one.
Yep. Scott's made a motion.
Yep.
Yep. And then if I can get a second, that would be great.
Jason Agnick seconded.
There we go. Great. Thank you very much. And any other introductory remarks I forgot or got wrong from maybe to Brandy or Alice?
Sorry, No, I'm sorry. I just got an email that I need to respond to about RVTEC right today, so I missed part of it. But tomorrow is the last event of RVTEC officially, which is John Haverlack's administrative mesh networking training. There's a little bit of homework involved, so if you are interested, you want to register today and start downloading the appropriate stuff from his Slack channel is one. Alice, you were going to mention something when I interrupted you?
That's okay. I was just going to make another plug for the annual meeting. So next week's sessions, we have our outreach and then our keynote speakers on Monday. And on Wednesday, we're going to committee overviews. And then the next Monday is when we have the ship updates. So those could be pretty interesting for the RVTEC group. You can go to the meeting webpage, and those 2 are all being recorded. And so you don't have to be there at the time of the meeting, and you can watch them after the fact. that's it.
Yep. Thank you very much. So should we go right into presentations?
I think so, yeah.
So first up is the Winch Pool. Is that correct?
I think I'm first up.
Yeah, I think
Oh,
we
no,
have JMS inspections first.
GMS, sorry, I just got the agenda. I closed the agenda. So first up today, we have Ted Colburn with JMS. He's going to give us an update on the National Science Foundation Ship Inspection Program.
Thank you. Good morning or good afternoon to whoever you are, and hope everybody's well and safe, and please stay that way. I'll give you a brief on the inspection program. It's called the National Science Foundation Program. They take the lead on it, and it's used through a number of other vessels in the fleet as well. So even though it's titled that, it's not just for National Science Foundation. Next slide, please. The purpose, several purposes. It's for the capabilities, assure that the capabilities of the research vessel and technical support meet the accepted scientific community standards and expectations. To assure the seaworthiness and safety of the research vessels meet standards like the RVSS. To ensure the vessels as capital assets are being adequately maintained, and to ensure the science is scheduled on properly outfitted and maintained vessels. You go to the next slide, please. We didn't have a very busy year this year. Since last RVTEC, we've only inspected 4 vessels: the Sproul, the Pelican, the Kuliak, and the Pacific Storm. Just to note here that the Pacific Storm is operated by a UNOLS member, but it's not part of the ARF vessel fleet. In background, we've done that before. The Hogarth and the Weatherbird are operated by a UNOLS member, FIO. Next slide, please. We also participated remotely with the Kilomawana new winch and Lars program. Scott took the lead on that, and it was really good to be able to do that and participate in that. I missed out seeing it live, but with the videos, the presentations, and the discussions within the group that were looking at it, it was very informative to me, and I hope we added something to it. But it was a good thing to do in a virtual framework since we could not do it in person. Next slide, please. What's happening? Well, the inspections are put on hold through at least 2020. Probably going to restart sometime in 2021. There's one penciled in for March, but that may or may not happen depending on what the situation is going to be. And the operators are working with NSF and others to look at possible dates to see when things are going to start again. Next slide, please. Now, since there are so many members or people here at this RVTEC meeting that I've not seen on ship inspections before and are new to the aspect of it, I thought I'd give a quick brief of how this thing goes. And it works similarly, whether it's an NSF ship or ONR ship or another vessel. We basically use the National Science Foundation, the plans for that when we go to aboard the other ships. Basically, it starts out with about 2 months before an inspection, NSF or somebody else sends out the pre-inspection information requests. There are about 25 different aspects that go into that, such as the past cruise assessments and what happened since the last inspection and things like that. That's very informative to us in preparing to how to optimize our time and your time when we go aboard a vessel. Then when we come aboard a vessel, we typically go with a team of 3 from JMS. And that's Blake. He does the operations, the safety, the habitability. Bill or Jack, they do the engineering, the hull mechanical and electrical, and I do the science mission support equipment. We often have, if it's an NSF inspection, we have an NSF representative with us. If it's ONR, we usually have an ONR representative. Next slide, please. We typically have, for the smaller vessels, 1 day in port and 1 day at sea. First day usually is the one in port and the second one at sea. That can change based on weather conditions, tide conditions, and so forth. And then if it's a larger vessel, then typically it's a day in port, a day at sea, and then another day in port. So it goes for 3 days. And that's typical, but it does change. When we're on board the ship, we'd like to see pretty much all the systems operate. We exercise the systems pretty close to the limits, and sometimes for like overspeeding on the generators, we take it to the limits. We don't ask, or we may ask, but we don't require operators to operate a piece of equipment if they're not comfortable with it. We'll work with them to find a solution or note that, if there's something of concern, that it goes in the report. But we don't want to put anything in jeopardy. We want to leave everything when we leave operating pretty much the same or improved from when we arrived. We look at the material condition, we look at procedures, training, things like qualifications and so forth for the winch operators, and a number of different things when we're on board. Before we leave, we provide an out brief or an exit brief. We give the ship's crew, the captain, representatives from the operator, and others as picked by the captain who he wants to be in the brief. We provide an exit brief which highlights most of what we discovered. And then we start providing a letter summary after that. Usually arrives within about 3 days after the report, highlighting the primary things we find. And then about 6 weeks later, we deliver a report on the inspection. Next slide, please. Just a couple observations where we see across the fleet that some more work needs to be done. There's quite a bit of progress on Appendix A, which is the UNOLS rope and cable standards. To aid that, we've been providing an assist sheet, and that assist sheet is available in the Slack channel. So if you're welcome to get a copy, or you can email me if you wish. Also, Alice and Brandy, I've provided them a copy. So should be available to you, and it should help you. Appendix B has got a long way to go. The overboard handling system safety evaluation, safety system. Here we have a assist sheet provided and done by Aaron Davis, which has been a great asset. There are actually 4 sheets depending on what framework you're working in, one for components, one for the system, one for PIs, and one for purchasing items. So that's also available on the Slack channel. Just to note that none of the vessels so far are in full compliance with both A and B. And some are real close to A, but ways to go in B. And that's a quick summary. And if there are questions, I'll look at the Slack channel and where somebody can pass information on to me. Thank you, and take care.
Thank you, Ted. Given time, I think we should probably keep going. And questions can be posed and monitored in the Slack channel. Next, we have Josh Eaton with the East Coast Winch Pool.
So, Josh, just so you're aware, we do have a West Coast Winch Pool presentation also. So just so you don't have all of the time.
Okay. Make up stuff. I'm good at that.
I know you're good, so that's why. Just letting you know. Thank you.
Okay, so are we ready?
Yep. Go ahead.
All right, so this is not the typical Winch Pool update that I provide. This year, that was provided by Brian at the RV or at the UNOLS meeting. And so that's available if you'd like to go check it out. What I'm providing is a couple of new developments that we've been working on, especially over the last year. So new and improved, shiny. So coming up, the first thing I want to talk about is our new remote access boxes. And my subcaption there is using up all the bandwidth because I know how the techs all love when someone just sucks up all the bandwidth on a ship. It makes everyone happy, so I'm very pleased to be able to do my part on this. So for this, I'm using a VPN router, so I'm not using the Hui VPN. This is a standalone device, and it can be triggered on and off to not allow VPN connections to come in. And so this way it helps control the bandwidth. This particular unit, however, it still wants to phone home to say, I'm here, you can connect to me, or I'm here and you can't connect to me, which is a little unfortunate. But again, for the ships, you can just disconnect it, don't have it plugged in, and we only need to plug it in when we need it. The Ethernet connector that I'm using is an Ethernet Bulgin 6000 series connector. It seems to be pretty robust. It's a little tricky to get the dust cap on and off, but once you figure it out, it's not too bad. So why do we want to do this? What is this good for? Well, it securely lets us access the winch data without just being open and broadcasting all over the place. It lets us remotely program the PLC or HMI or help with some advanced troubleshooting that we can do. So if one of our winches has developed an issue, hopefully we can go in and access what's happening and better point the technicians to what the problem is. Or if it's one of our winches that we've programmed, again, we can edit the program to either allow you to do something that we never foresaw, or, do something a little bit safer. It also can let us reprogram the MRU. So if something moves on board after we've set up the MRU, we could tweak that configuration for better active heave performance. The dangerous aspect of this is that I could theoretically drive the winch from shore, and I'm going to say that should never happen. I don't think that would be a fun experience for anyone except for me, because I'm back in my lab. So we also have some new remotes, and I'm really excited about these. I'm sorry for the moire pattern in the coming pictures. I might pass by some of those pictures and we can log directly in because I have the VPN set up. So our old remotes, they only work with the MASH winches. They were heavy, they were large, not really easy to handle. They were fairly robust, but over the last few years, we've had units start to to fail. And so we tried to decide, what should we do? Should we recreate the old, or should we come up with something new and better? And I think we did make a large improvement. So this is the new remote. It's much smaller, it's much lighter, and it's compatible with both the MASH winches and Gloria, which is our Hobalt winch. It's also let us introduce some new features. And one of the new features is to stop you guys from doing this. Please stop Velcroing the joystick handles. This is not safe. It's not a good idea. I have to clean off all the sticky goo from the Velcro. So we have a new auto payout feature. All right, so I'm going to change my screen. And I'm going to set it up. Well, that's not what I wanted, but that's okay. So our remote connection is through a web interface. And so you can see all the devices that we have, what they're associated with, what name they've been given. So right now I'm going to connect to Gloria. So you can see that right now the remote is connected to the internet, but the VPN is disconnected. Now we did practice this, so hopefully it doesn't disconnect me and throw me onto this VPN network. And it looks like we're still okay. So we've managed to connect to the VPN. And so next we can actually go and we can take a look at some live data. And so this is one of the PLCs that I have connected. And if I go to connect, I have to know which one I want. And of course, when it worked earlier, when we tried it out, that's okay. I have other things that I can demo. So this is another one of our programmable controllers. And no. All right. So I guess, oh, it's because I'm not connected. That will cause the trouble every time if you don't actually connect. So I should have paid a little bit more attention, should have seen that I was connected. And now if I come here, still not going to want to cooperate. Try 2. So this is live data coming in from the winch. So I could pull up all the variables that are on the winch, and I can check to see what the status of each input to my PLC is, along with pushing out new changes to the PLC if need be. And then the last thing that I want to show, we are going to change the share view. And that should not be very pretty at the moment. So this is connecting to Gloria right now. And again, this is a live view of the new Winch HMI. So we have a live graph, and it auto scales for the tension that we see. I find that this graph is a lot easier to read than the LCI 90i graph, I find that one to be a little too stuttery. Again, we are recording the maximum tension, the maximum payout, and the maximum speed. We have a button to reset those maxes. So after you write them down for the wire pool, you can reset them and capture the next set. So the HMI has several pages. Right now, our home page is line data. So our next page that we can go to is data options. And this gives us the option to make the screen brighter or darker. It also gives us indications of which functions are enabled. Right now, none of the additional functions are enabled. So we're going to go to our troubleshooting page. Again, this shows us that we are getting the live data. It shows us that we have remote access. I really hope I don't accidentally click on that because the rest of the demo goes downhill if I do. So from here, if I want to access some of those higher functions, I need to enable them. So once I log in, it gives me a few more options. This is not something that technicians should have to do. It should be enabled and stay enabled on the vessel. And you can see when I logged in, we got 2 new options here. And then when I activated auto deploy, we have an additional option here for auto deploy. So this is the spooling page. Again, this is something that technicians shouldn't have to access. This is more for us to set up the parameters and the Appendix A safety factor, along with what tension member and how much wire we have on the drum. So now if we go back to data options, it gives us, we can see that these 3 functions are now enabled. So occasionally it might be useful to remote zero the winch. On our winches, the zeroing is all done at the local control panel. So this gives an option to zero at just the remote. So it can cause a little bit of confusion. That's why we typically don't have that on and active. Auto deploy, we're working on testing, and so that'll be coming out soon. And this last one, I think, is pretty interesting, payout compensation. So what that is we found that when we spool on a synthetic tension member, we found that our payout is roughly 90% of what's displayed. And that's because the synthetics don't quite spool quite as nice as cables. So this lets us get a little bit closer on our payout. So we could enter in a number here, 90%. And again, I have the raw payout is 7, the corrected would be 6. So that just gives us an option to be a little bit more accurate for those users that are using a synthetic tension member. Coming back around to the auto deploy, this is hopefully the fix, so people are going to stop Velcroing the joysticks. This lets us adjust a speed. So if you want to set a maximum speed, this will set the maximum speed that the winch will go to. And we have a graph here of showing where we currently are and what our target is. And so we can adjust the depth that we want it to go to, and the winch will automatically pay out when you hold in this button here. I'm not going to press it because, well, it would be cool if I had a camera on the winch and we could all see it go crazy, but we don't want to freak out Jamie in the shop right now. So just by holding in this button, which is just your thumb on the screen, instead of having to hold a joystick, it should make it easier and should make it more straightforward, but still be responsive to the user and check to make sure that there's someone there. As long as no one gets the idea to use a hot dog. That is not a workaround, so please don't use it. So I think that's about it for the new remote. So if there's any questions, we can go to questions. So I'm willing to answer questions.
It looks like there's a couple of people that are typing in the Slack, but they haven't quite got through yet. So maybe we want to give them a minute. We also have plenty of time. So I don't want to rush. Oh, here we go. Gabe Mathias. Will it auto recover to any entered target depth?
Not to any entered depth. I've set the limits to our safety depth, which we consider to be 10 meters. So from the point that it's been zeroed, it will recover 10 meters to that point. That's just hopefully to prevent some amount of tube blocking.
Okay. He followed up with, for instance, in the case of Toyos, but I think that still explains.
Yep.
Don't bring your Toyos to the surface.
So, if they're towing and they have more than 10 meters paid out, it will go all the way to their set point until they let go of that button. And it automatically detects whether the target is more or less than the amount. So you don't have to select, I want to haul in or pay out. It will, if you set your target to deeper than the current depth, it will pay out. And if it's shallower than the current depth, it will haul in.
Lee asked a question, and I think this is for both of the winch pools, so maybe Aaron will pop in with his response later, but can the winch pools share any experience about the use of the new Hobble mooring winches?
We have not had ours deployed yet. The report from Aaron has been very positive. Ours is looking to be going out, I think, sometime later this fall or early spring, as we know how cruises are kind of up in the air at the moment.
We have a question from Robbie. It sounds like all the joysticks are spring-loaded. Are we allowed to use joysticks that stay put?
I don't like them. I'm going to be perfectly honest. It's, again, our clientele aren't necessarily full-time winch operators. A lot of scientists are using our equipment, and it's too easy to not have it spring back to center. So we consider it safer to have spring return. There are some ships and institutions that do have friction lock joysticks. I don't know that anyone has said, no, you can't have those. But for the winch pool, we don't care for them.
Right. Lynn commented, I was just going to ask if it can toyo and pause and restart. Thank you. Which, by the way, Lynn is joining us from C at our Virtual RVTEC, which I think is kind of amazing. And we still have someone typing.
Hey, Brandy, while we're waiting, could I chime in about the new mooring winch?
Aaron joined us. Yes, please. Thank you,
Okay,
Aaron.
so we got a new mooring winch last year and we've been shaking it down. It's went to sea twice now. And the results were very positive. Initially we had a hard time trying to hold the load when we stop and start. It wasn't really holding the load in place. It would drop it a little bit before we hauled it in again. But that was just a setting on a motor drive that we changed. And with that exception, everything's been pretty promising. It clears everything. The level wind is pretty handy. It clears a lot of hardware up to about 6 inches in diameter. And we were reeling mooring hardware past the level wind without an issue. So that was very nice. Yeah.
That's great. John Millett would like to ask Josh if you have any review or feedback on the VPN router they're commonly using, the E1 COSY 131, EWON COSY 131.
I started out using that. That was the first one that I purchased. The one that I showed is far less expensive. It's half the cost, but I was getting just as good connections over the E1 as I have been over the Stride links. I've also used another one, and this is not helpful or useful because I can't remember the name. And that other one worked as well. And I don't know why I brought it up because I can't remember what model it is. So.
Aaron, we have almost 15 minutes. I want to apologize to our VTech through an administrative error on my part. I didn't get Aaron the information he needed to join us today, but he made it. So if you want to take that time and share your presentation, we have it available now.
Sure.
Dad, I coded something really awesome.
I want to know what's awesome, though.
My son coded something that's awesome, he says.
Oh, that's great.
Sorry, waiting for me to share. Oh, okay, there we go.
Alice is bringing it up.
Okay, hello, my name is Aaron Davis. I'm here to talk about the NSF West Coast Winch Pool, operated by Scripps Institution of Oceanography. Next slide, please. And before I go on, I'd like to say it was not Brandy's fault that I got here late. I didn't even realize we had to register or anything. I just got a reminder today that I had to present today, and I looked into how do I go about doing that, and I hadn't done anything I was supposed to do. So my fault. So you probably already know a lot of this from Josh's presentation, but our mission is to provide you with an inventory of oceanographic winches that you can borrow, to keep it in good repair, to add things that our community demonstrates they need, and to get rid of things that are not working well or not needed anymore. We also provide technical support, such as engineering and fabrication. We do cable and wire rope spooling, maintenance, and whatnot. Next slide, please. How it works is science parties let us know what they need. We try to match them to a piece of equipment that'll suit their needs on a first come, first served basis. Those conducting the NSF funded research don't generally have to pay to use the machinery. Others pay a day rate. It's basically just a daily rent and the cost of getting the equipment to where it needs to go. Next slide, please. Our spooling services are done at no cost to NSF funded projects. The operation of most ships is an NSF funded project, with the exception of some commercially owned ships and NOAA and whatnot. The spooling jobs are also done on a first come, first served basis. We generally need a lot of time to plan them. So if you can get us a heads up earlier rather than later, that's helpful. Most winch pool or most spooling projects are less than about $15,000. So we can usually absorb them even if we haven't requested the funds in advance. And non-NSF funded projects, vessels operated by NOAA and others, they have to pay for the cost of our spooling services. Next slide, please. The pool is operated by or managed by Captain Eric Buck, and I am his sidekick. We also have a technician, our lead technician, Lorenzo McCoy. We deploy him to mobilize and demobilize our more complicated systems like our Dynacon 664 winch system. Next slide. We're almost exclusively funded by NSF. Our expenses, we estimate them annually and put them in a proposal. Engineering services, that's my salary, so that's included in our proposals. And so any engineering I do on your behalf is done at no cost if it's for an NSF funded project. Others just pay an hourly rate. Our major repairs and the big expenses, we write them up in separate proposals, and all the routine maintenance we do on our equipment is covered by that day rate I mentioned earlier. Next slide, please. Here's our inventory. We have 2 light duty winches. Those are something like a CMAC winch, something of that size. 4 TSC mooring spoolers. We have a new mooring winch that was mentioned earlier. I'll elaborate on that. Our Dynacon spooling winch, a Libus mooring capstan, our larger Dynacon traction winch, and I'll show you details in a second, some photos and whatnot. Our marking tensioning spooler for our spooling work, 3 line tensioners and some slip rings as well. Next slide, please. So these are our light duty winches, our Hobbled SPR 2036X winches. They are comparable in size and capabilities to, say, a CMAC winch, but they do offer a modern PLC control. And one of them also does auto casting, similar to what Josh was describing earlier, where you can you could put in a table distances and speeds. I think there's up to like 100 entries, but so you could do something like a Toyo. You just deploy one step like casting out, and then you tell it to keep going, and then it does the next step and the next step. But we have 2 of these to offer. Next slide, please. These are our mooring spoolers. We call them not winches, even though it looks like a winch and whatnot, but they're just not as robust as an oceanographic winch. So we loan these out to basically to deploy moorings onto the surface of the ocean. So something like an anchor last deployment, or get them back off in the same manner without actually lifting the anchor. We have the new mooring winch for heavier duty jobs. And next slide, please. This is our new mooring winch. It's all electric. Josh may have shown you something about it earlier because theirs is identical. Third one was also made for BIOS, but it's hydraulic. And so far, we're really enjoying this thing. It has a tension readout, as you can expect. It holds just as much line as a TSC spooler. It provides 10,000 pounds of pull, which is significantly more than those spoolers. And it withstands up to 20,000 pounds pull. I don't know what else to say about this. Its default mode of operation is just like the TSC spooler. You have one joystick that pays in and out, and one joystick to operate, to manually operate the level wind. If somebody wanted to, however, we can also use it in an automatic mode to spool pretty much any line up to, I think, 3/4 inch, but it depends, as long as the breaking strength isn't too high, to automatically spool it just like any other winch. Next slide, please. This is our Dynacon mooring spooler. It's gigantic. It has the same amount of pull, 7,500 pounds, as our TSC spooler, but its capacity is a little bit more than twice as much. So this is for deploying something very large, and you'd have to really need it because, next slide. Like I said, this thing's ginormous. This flatbed includes a spare spool, but you can see that this is going to take up the whole working day. Next slide. This is our Libus mooring capstan. It was purchased primarily to service the OOI moorings, but others can use it as well. We just have to schedule them in between the OOI mooring servicing. Next slide, please. And this is our Dynacon 664 winch. That's our heavy duty winch. It holds 10,000 meters of 681 cable. But it can also handle 9/16 3x19 wire rope. And year before last, it was fitted with a 9/16 synthetic tension member to do some coring work with. So it comes with the instrument block, and we have slip rings for it as well. Next slide. This is our Markey tensioning spooler. It's what we do all our spooling work with. It looks pretty large. Well, maybe it's hard to tell the scale, but it's a pretty large system. But we designed it so that it would break into pieces. So the bull wheels in the foreground, they disconnect from the remainder of the system, and the level wind actually folds up. So we can actually stuff the whole system into 2 20-foot containers or 1 40-foot container, either way. And then we could ship it anywhere in the world we need it. Next slide. And these are our line tensioning devices. The Markey tensioning spooler can provide 2,000 pounds of tension, but that's not always enough. We use the yellow one, the Pengo tensioner, quite a bit for larger direct pull winches that need, upwards of 10,000 pounds or more of tension. That just has to be chained to a vessel's deck or something before it goes onto the winch. Next slide. What we've been up to. So we did a group purchase of 5 winches for BIOS, us and Hui, including the mooring winches and 1 light duty winch and another smaller winch for the Atlantic Explorer. We accepted and tested 4 of them. Hui accepted and tested their own. And then let's see, made a new fire plan and some hydraulic diagrams for Sproul. We're getting a new level wind for one of Sproul's winches made by Markey so that it's Appendix A compliant. We could use the lower safety factor anyway. Yeah, we had to construct a new intersection for Roger Rebel's squirt boom. It had seen quite a bit of corrosion and needed to be replaced. And we got, we're getting new sheave treads for our flagging blocks on Rebel and Sally Ride. They're currently a big plastic circle, and you have to disassemble the entire flagging block to change them out. We're going to have some that are made in pieces. They're halves instead, so you can unbolt them and change the tread without disassembling the block. The idea was that it would allow us to change between 9/16 wire rope sheaves and 6/8 sheaves to get a better to be able to use a lower safety factor on our wire rope. And then, oh, that's worth mentioning, I researched some requirements for portable cranes. I was asked to, the cranes on ship obviously have to meet requirements for the Classification Society and other stuff. But I was asked to look into what about these portable cranes? Sometimes we move on board and off of ships. And it turns out I discovered something pretty interesting. And that is, if a person is moving things around a ship, on or off a ship or around a ship, regardless of what it is, if they're not part of the vessel's crew, then they're considered a longshoreman. And the cranes they use have to meet federal requirements for longshoremen. So if you want to know more details about that, if you have a portable crane and you want to know what sort of things you have to be complying with, just give me an email or something and I'll elaborate. And then we're working on an amendment to UNOL's RVSS Appendix A as we speak. And that concerns systems that use both 9/16 wire rope and 6/8 or 6/8 cable. Their grooves are too big for the wire rope, so we tend to have to use a very low safety factor. But the wire pool did some research on this matter this past year, and we're going to try to use the results to figure out what to do about this case. Next slide. And that's it. There's my contact information if you have any questions, and my bosses. If you want to, our website address is very long, so rather than putting up there, if you just search NSF Winch Pool, we're generally like the first or second hit. That's all I've got. Are there any questions?
sorry, it looks like Robbie has a question. How many channels, fiber, electric ratings on the slip rings, etc.?
The slip rings are pretty large. They're for 3 fiber optic channels and 3 electric. They were specifically made to go with the 6.8 to work with the 681 or 680 cable.
Okay. That's all that we have for questions now. Thank you, Aaron. I'm glad that you made it today. If there are more questions, go ahead and drop them in the Slack, and we'll make sure that Aaron gets them. Josh, I think you had a few more comments before we go to break.
Yeah, I had one more thing that I wanted to share. It's something that I started end of last year. And I started to look into effectiveness of active heave compensation. And this particular chart is an active heave compensation cast from the Armstrong. In order to get some better data, if anyone would like to share their active heave compensation casts and would like to talk about data collection for that, I would love to be able to do that, to be able to get some more data on the effectiveness of AHC. And just some of what I'm doing is, you can see it, we're getting relatively nice matchup. This is with AHC off, so we can tell that our motions are matching pretty well. And then we do some combination analyses. But I would like some more data just so I could have fun with it, basically. And I think that's that.
Great. We had one more question for you, Aaron, real quick. Are the slip rings focal products?
They are.
There we go. Well, thank you. You want to go ahead, Lee, and wrap us up for a break?
Yeah. I think we'll come back at 11 o'clock Pacific. Thank you to all the morning presenters.
And the stream continues live, so mute your mics and turn off your cameras for a few minutes. We'll be back on the hour.
Okay, are we ready?
Yeah.
Let's do it.
Okay. So next we have a session of inventory management. So one reason, of course, is important for instrumentation, but another aspect of this, sometimes called asset management, is for cybersecurity. So these are, I know we've looked at scripts, we've looked at some different systems. I've heard of other systems in the fleet. So first presentation we have on this topic is from Connor Ahern and Hannah Brewer, both with Woods Hole Oceanographic Institution. Ready to start?
Ready here.
I'm ready.
Okay, go for it.
Great. Hello, RVTEC. Thanks for having us. This is my first time here. My name's Connor Ahern. My co-presenter is Hannah Brewer. We both work at the Woods Hole Oceanographic Institution. And the slide that you're hopefully all seeing is just an overview of our little port here. Here today, just thank you, Lee, for that introduction. We're here today to talk about a software system that we've been working on, a project that we are collaborating with others at our institution, and it definitely works in the inventory management world and asset tracking and a number of other data necessities. Here at the institution and for the groups that we work with, we have had a problem keeping track of stuff. It's not an uncommon problem, and in research fields, I think in particular, there's a different acceptance of some of this. You do things one-off, and you work through your projects, and it's really hard to keep track of the different ways that you've worked and the different assets you've used. And so when I joined OOI, which at WHOI has a smaller group called CGSN, they were really getting into their operational mode and had lots of material, and we're doing a pretty good job of tracking it, but the problems that we would hear over and over were really common. And these are the problems I think that lots of us here can relate to. I mean, this is the time you pick your head up from a long week of work and you kind of turn to somebody and say, where's that, instrument or the gearbox that we're using or the spreadsheet that tracks all of this? Or you might work with somebody over a number of years and then think back to yourselves, like, how did we do this in the past? How did we put these things together? And those opportunities to track that stuff was something we were really running up against after a number of years, having a really hard time. So we had reams of spreadsheets, and really this is a problem. In any lab I went into at WHOI, people often had spreadsheets that they were tracking their stuff on, or maybe a drawer full of handwritten notes. And then at the worst version, there's just one person who's keeping track of this all just in their own mind. And we really needed to find a way to be more consistent about how we were going to track this information. And we had a number of challenges. It wasn't just as simple as dumping those spreadsheets into a new system. We had to find a way to connect these things. And the project was really valuable. It was important because we were losing some opportunities in all of this. So we looked out into what was available for software products. And again, when I had come into the project, we were using sort of an industry standard, some production line manufacturing process software. And it never really worked out for us. Anything that we were putting out into the ocean had to be brought back to us as an RMA. And that just wasn't really viable. So when we thought about it, we realized that what we were trying to do was just completely different in the way that you think about it. In industry, a return is a failure. And so it gets like an RMA and it gets shuffled off, and it's a really linear process. But for us, this is like a cyclical process. In oceanography, if you get a return, it's a party, right? Like you want to really celebrate those things. And we needed to really start to rethink how we were doing our project. And so we came up with this idea that what we needed to do was track our materials and track our documentation and be able to see it as through its whole life as it goes out and it comes back. And we needed to do those things and also manage the metadata that comes along with it. So this slide here is just kind of showing those several things that we were thinking about having to pull together and be able to see over a full lifespan. But any of you out there who are encountering these problems probably have your own set of concerns. I mean, there might be some real cost analysis that you need to do. Like, you know, are you using your materials the way that you want and the way that you feel like is best? And you can help your budgets that way. Or, you know, how are these items performing over a lifespan? It was really difficult when we would go to our vendors trying to figure out, you know, how many mating cycles do my connectors get on this product? Or if I put it out, you know, a bunch of times through these conditions or over these many years, it was, I think that the community in general kind of experiences that there's not a lot of help you can get in these places. You have guesses, but we were losing the opportunity to track those kinds of things. And then you may be finding those same opportunities lost. So a new system was something that we really needed, something that could track and organize metadata from all different kinds of parts, whatever it is that we wanted to track. We couldn't do that in a cyclical manner. So what we came up with was an open source project that we started. We started this project that eventually came to be called Roundabout. And so we call it the Roundabout Database, or RDB. And what it is it's a way to track, collect, and organize the electronic records of your high value equipment. This isn't intended to be dealing with expendables, O-rings and stuff. Different labs that you go into, some people are really concerned about those smaller items that they go out to see and they run through a whole lot of, and we have ways to track this, but this is really for your higher value items that if you knew more about its lifetime and could track its history and not have to spend time searching those things down, that you'd be freed up to do more and better work. So Roundabout, when we set out to do it, what we have created now is a system that will track the history of your individual inventory parts. And it'll maintain those records of the parts and its sub-assemblies down to any level that you want. We had limitations in other software products that we couldn't go down to any level of detail, but in Roundabout, you can go to any level of sub-assembly that you want. It's interactive. Well, we imagine this being the kind of software that from top to bottom in your group, somebody could use it day to day or come in just occasionally and get what they need out of it. It's searchable, and all of the data that's inside is importable and exportable. So then when we think about how Roundabout should be organized and what we want to do, the work that we want to do, we realize that we care about the life cycle of that equipment. And in order to organize and provide the information about it, what you need to start thinking about is what do you have and where is it? And so for Roundabout, the way that we solve this problem of tracking these things is that every piece of inventory gets a serial number, a unique identifier, and it gets a location. It will always have those things. There's other relationships that we can make. We can attach children parts or put this on a different parent assembly. We can change and modify any of the data that's in any fields that you want to create. We have custom fields available, and we can do a lot more functions, but at its core, all of the parts will have a serial number and a location at all times. And this can be a real struggle. So every group kind of comes to this process when we've spun this out at WHOI to a number of different groups, and Hannah will speak a little bit more about her experience there. Every group kind of struggles with how their common language works and whether or not they already have a system to serialize. And the wording that they use, you'll find that when you're going to do this work, that settling on some common language proves to be a little bit more difficult than you would have thought. And like I mentioned, Hannah, I think will say more about that later on. So the way that we structured the actual data entry is to break our system up into two parts primarily. So you'll see here that there's this is kind of like the notional structure of Roundabout. We have a set of templates that kind of back end all of the data that comes into Roundabout. And on those templates, you can assign and structure them however you want. We have part templates. You can imagine these as the empty bins in your lab waiting for inventory to come in that categorize what kind of parts you have. And those will just allow you to keep track of that kind of information by each part. And then we also have a template for how those parts are assembled. We call those assembly templates. And so you can put them together in any kind of novel way that you want to match how you built something this year or how you intend to build it forever. And so when you have those templates set up, then you can actually enter real inventory. And breaking things up into this way allows you to track things that are true across all of a part type. And then when you actually get the inventory, then you can put in specific notes that are particular to that individual part. And so the things that we're currently tracking in this are things like sub-assemblies, the costs and the manuals that are associated with all the things that we work with, different ways that they're configured, and any other metadata that you might want to capture. We have the ability to make custom fields so that the users can decide what they care about tracking. What I wanted to do now is just quickly show you what the system looks like. So here, this is a live look at our demo site for Roundabout. It's web-based, so you'll access this. Most people would access it through a browser. You can do back-end work so that you're autofilling with code as well, but if a user were interacting with it, this is what they might see. So what I've already kind of laid out here is maybe a couple of kinds of things that you might care about, some CTDs and an ADCP. And this is just what it looks like to have inventory in Roundabout. So this is here at RVTEC conference, we have a CTD that's waiting for us. On the left-hand side here is a tree structure that helps us navigate all of our inventory. When you click on something, you get on the right-hand side a display of the different information about this specific part. So this is CTD serial number 5, and it has some set of part information associated with it. If you are working with these parts in the field, you might find that you wanted to track other things about it, like maybe the way that you set it up. You can take pictures, you can make notes, and you can do that all through this interface. There's a set of tools over here under this choose action button. Here I'm showing the ADCP. And you can do a number of things, move it around, location changes, and put notes in. Beyond that, what you would want to do next after having some parts in inventory is build up. So in this case, I have a ship here that has a bridge and a hull and a van, and they may have different parts underneath them. You can expand and collapse them. So like I said, you can go down to any level of inventory. Once you have a build like this to say, hey, my ship has some parts on it that I'm expecting. When you click on these empty slots, Roundabout will actually check your whole inventory to see some parts that you might have. You can do this bi-directionally. You can go to the individual part and add it to your assembly, or you can go into your ship in this case and look through your inventory and pull up a new part. So you click on that and you can pull that in. So the CTD now is added to this rosette. And we have, just this whole inventory sort of to work with. I also mentioned that Roundabout is searchable. So quickly just want to show you that this is another quick look. This is our search page. We can search any parts that are tagged as RVTEC parts. And in this case, I've already done that. They're linkable back to the individual parts. And then you can also output this as a spreadsheet or in any other fashion, a CSV or whatever you need to, so that you can build little reports along the way and see your stuff. At this point, I'd like to introduce Hannah, my co-presenter here. Hannah, I think you should be able to bounce in now.
Okay. It says you have to stop.
Stop here.
Yeah, I had, yep, just one moment.
Oh, went ahead. Okay, sorry for the clinkiness there, but yes, I'm Hannah, as Connor said, and I work in the Ocean Bottom Seismic Instrument Center at WHOI. And I came in, Roundabout was already part of our group, and I started using it a lot, entering inventory, making part templates and assemblies, and just became somebody who was really using it a lot and then became the point of contact in our lab. So I did want to start off showing our OBSIC timeline because I think it's really helpful for other groups to kind of see an idea of how long this takes. Like, it does take a while. There are certain things to set up. You're not just diving right in. Also, I think it helps show the nature of oceanographic instruments and the parts you need for it. So our instruments are gone for a year. So that means it's going to be a year before we can get everything into that system. So like Connor said, spreadsheets is kind of how we track everything. That's how we tracked absolutely everything in our lab. And it's okay, but it could use a lot of improvements. It's difficult to track the history of a lot of stuff. So you don't have just a consistent idea of what's happening with one part. You have to go find every single spreadsheet that it's ever been on, which takes a lot of time. Also here, all of our information is on one line and in one field. So the parts serial numbers are mixed in with the metadata, which is very important, but doesn't really need to be on that same line. So here you can see are all of our serial numbers. So like the top level of the part or our instrument. And then these sections are our metadata, which I said is really important, but mixing them together, it does make a lot to filter through. So then here in Roundabout, you can see it's broken up a little better as Connor just showed in that demo. So here you have these top level parts. You have your part number and your serial numbers. So it's the quick glance of what's on the instrument and what the relationship is. And you also know exactly where it is and you can look at it individually if you'd like. And so all the metadata, we didn't get rid of it. It's down here in the custom fields, which there are much more. I just couldn't fit it all on one slide. And you can make as many as you'd like with the titles you would like. So they really, custom fields, best name for it. And they're very helpful. So here is the part that the spreadsheets are lacking, the history. So there is a whole history tab like Connor just showed with the notes. You can add pictures. All the updates you want to put in are there, and it's really helpful for people to look at. Also, we have the total time in the field, which you can see right here. This one is at 0, so it's not the best example, but it's there and it's really helpful. And you also have a couple other things that are helpful, like the part type that it is and current inventory. So another great thing about Roundabout is how flexible it is. So you don't have to just use the version that you receive when you get it. I'd say get in and start using it. And I think that's the best way to figure out what really works for you and your lab and your workflow instead of just using something that isn't helpful. So for example, this is the deploy and recovery feature. And I just started using it recently and I think it's really great. It's what triggers that the total time that I just showed you in the last slide. And so for us, the initial deployment and the burn in really wasn't important for our lab. They weren't steps that we really needed, but for other labs, they're great. So we were able to just take them out and all we have now is deploy and recover, which is what's really important for us. And so on the other hand, there's other features that are great, but you need to expand it a little bit. So in the test feature, there was only ingoing and incoming and outgoing, which is okay for some parts, but some need to be a little more specific and need multiple tests in there. So for this cable, things that we need is pressure test and the cable eye. So now at a quick glance, you know, it's past both of these and we can use this cable. So for other labs, they might just need that one, but we wanted more and Roundabout was able to do that for us. So going through all this, we were able to improve a lot of things in our lab outside just the inventory system. So our team communication really improved. If there was an obstacle, we knew who to talk to, and we can also either talk to the group about it if it was a big problem, or we could just talk to do it individually and figure out the problem. A lot of things became more consistent, like our practices and our workflow, because we knew this is when things are being entered into our inventory system, and then this happens, this happens, this happens. It really made more of a workflow. Also, like I mentioned, our vocabulary became much more consistent because we had about like 3 or 4 names for one part, and then one person called it something, another person called it something else. But once we started giving a part a name in Roundabout, that really got people like to say, okay, we're calling it this now, which was really helpful, especially coming in new and one part has like 5 different names. So I was sometimes looking for 5 different parts, which were 1. And also our overall lab organization, Connor mentioned that you can put things in different locations. And so that translated into us really keeping the lab more organized and be like, okay, well, it's here in Roundabout. I'm going to keep it here in the lab. So we all knew where things were. So integrating it, like, how do you Roundabout? How do you make this all work? One thing that we found was really helpful was appointing a manager, and there's differences before and after. So before, there really wasn't one clear person to bring new ideas to or ask questions, and not somebody always like making a push to be like, hey, remember the new inventory system? So now that we have one person, everybody kind of knows where to funnel their ideas and questions, and always somebody kind of pushing it along to make sure it's not forgotten about. The organization, I'd say, was really the most lessons learned for us. And I'd say if how much you can get this set up beforehand is really, really helpful. So the part numbering scheme, it does have a suggestion in Roundabout, but it really is what you want to make it, what works best for you. You can have different ones for different parts, like cables and sensors can have different types. Ours are all like the same characters and just the numbers are different. Serialization also goes into that as well. And ours is based on it. So it's really important to get this figured out beforehand and then start into it. In the timeline I showed that we really gave a lot of time to this, and I think that was a really good decision, and it's really helped us now. Locations, the top level I think is the most important thing to get figured out before you start, and then under those will continue to develop. We're still bringing in new locations as we come across them in our workflow. Clarifying vocabulary, like I said before, it's just really helpful that you all know what you're talking about and just give it one name. And that will happen when you have to enter the parts into Roundabout. Metadata requirements, if you're really organized, that's great, but seems like it's a lot of places that we keep all these things. So it's helpful to get that organized and then start putting it in instead of just as you find it. It gets more clunky that way. And I would also suggest trying to figure out what you really want in there instead of just putting every single number you've ever acquired about a sensor into Roundabout. Using it in the field, it is possible. I've done it twice on 2 cruises, and one, it was just kind of regular inventory and maintenance, and that went really well. And then the second time I was doing deployments and recoveries, and that also went really well. So you do have to rely on shift Wi-Fi at this point, which I think we all have experience with. So I think we all know that's in and out, but hopefully there are some developments coming with that. And then if you are on the ship using this, then that's your home base and it'll work for you. I think setting proper expectations and staged implementation is really helpful because it's not all going to happen at once. There's just too much. You need to organize it. And let's be honest, you have other things to do. You're not just going to be the one person doing all the inventory and then it's just all magically together. And I think knowing that it's going to take a little longer than you expect and some of the decisions you may have to change. I think that's all important to know going in. And then you're able to see all the benefits and not just how long it's taking. So that is it for me, and I will hand it back over to Connor.
Thanks, Hannah. We are at the end of our time here. There were a couple more slides that you guys can feel free to check out. We dropped it into the Slack channel. There were 1 or 2 questions. We are really open source. This is the link that you can find us on GitHub. Feel free to drop us a line. These are some of the technical considerations thinking about spinning it up. It's pretty low weight. You can get it on a laptop if you need to. And we'll be glad to chat more about those things. There's other things that we had intended to talk about, don't have time now, but definitely hit us up in the Slack channel and we'll try to answer any other questions. Thanks to our team. Thanks to everybody here at RVTEC. Really appreciate it, you guys.
Thank you very much for the presentation. Great. Alice, Brandy indicated you wanted to introduce the next.
Sure,
speaker.
yeah. I wasn't sure if we were going to go for questions with them first, but if we want to go right into the MFP.
Oh, do we want to go right into that? Questions we could do in Slack, but I think we're on a time limit.
Okay.
So we should just go right into the presentations and handle questions in Slack.
Okay, sounds great. Well, we only have a little bit of time, and there's just so much good information out there. So I was just going to give a brief introduction to Beko Maas. He's from the Netherlands, and he's the lead developer for the Marine Facilities Planning application, what we're calling MFP. It was originally developed for the UK and the Netherlands for their academic research vessels, so specifically for academic research vessels. And it is now used by a whole host of other countries across the world. The UNOLS office, we've been advertising MFP as an STRS replacement, right? We're getting a new scheduling system, which is really true, we are, but we failed to mention that this is so much more than just a scheduling system. It's a fully integrated program covering everything from when the scientists enter their information, to the scheduling, to the cruise planning that's integrated with that scheduling, and then the personnel management, and then the inventory management, the reporting, and just about everything else. And I know it sounds too good to be true. It's been operational now and continually improving, I will say too, for a number of years. So Beko had mentioned earlier when I told him about this, he said, geez, I could spend 2 days going over the inventory management system. There's just so many intricacies to it. And we only have 25 minutes. So if there are features that you would like to see but haven't been mentioned, I encourage you to ask questions in Slack. It might very well be that those features are there, but we just didn't have time to go through them. So with that, I'll hand you off to Beko. Okay, you're muted, Beko. Are you muted? I think I hear you now.
I just unmuted him.
Thank you.
Oh, you unmuted me already. Sorry, I normally never mute myself. I have to get used to that. Good, thank you, Alice. Okay, that costs another minute of the already short 25 I have. Good. For today, very quickly, I'm going to tell you about the inventory management module, which is part of the broader MFP system. Although it's about inventory management, I kind of think it's important to have a quick peek at what the whole MFP as a system is. So I want to talk about MFP as an STRS replacement and how that integrates with the IMS module. After that, we really dive into the inventory management. So talk about the equipment database, about the fields we have, maintenance, tracking, how you move equipment around, voyages, transport, how you can make your planning to support that. And at the end, I would like to show a few sheets of the offline app that we have. Okay, so the marine facilities planning. It's a web-based system that was created together with NIOS and NERC, two European research organizations. And the initial project was called Track and Trace. It was originated in 2011 by NIOS. And the original goal of the project was to comply with the customs warehouse regulations. And what that actually means is like equipment tracking, knowing exactly where your equipment is, where it has been, how it's been brought back into the country, etc. And when we had that system, it was kind of, okay, we now know all that information, and it would be a pity not to kind of make use of that and extend that functionality and to bring in things like maintenance and calibration, things like that. And when the Brits from the UK joined the project, it was built into a multi-tenant system that was actually built as a framework. That's something that I really want to tell you today, is that what I'm going to show you are screenshot, but it's a really flexible system. We designed the system with the idea in mind that it should suit a wide range of different institutions. Institutions very large with multiple ships, or the smaller one just doing regional research. So the system now, we have a European platform that's been used by different institutions, and they actually use that to share information. We have two different systems in Australia, one in Saudi Arabia, and we're now doing the UNOS implementation. We're also doing kind of test systems with a whole range of different institutions in the world. But that's not important right now. Let's talk about the MFP. And I say it's a multi-module system. I can't show you all the modules, but what I do like to show is kind of how does that information all works together and on all the modules. So typically, it starts with the scientists putting in their proposals. And from all the proposals in the program construction module, you would create the ship schedules. And that is actually the starting point of a very detailed project planning, which is done in project management, but also the equipment planning. That is what the inventory management is about. And the system also supports technician and crew planning functionality. And built on top of all of that, we have the overall reporting functionality and an app that supports offline usage on the ships. Like I say, it's about inventory management, but let's start with just touching on the STRS replacement. So there are some things where it actually communicates with the inventory management functionality of the system. So in the proposals, a scientist can tell what kind of pooled or portable equipment they need on their crews. It is a very flexible screen, as in you can very easily add different questions to each particular item. You can add equipment if there's new equipment on the market. And what's interesting is that you can also link responsible people to different pieces of equipment. So if you, for example, request equipment from a pool, you could automatically, or the system will automatically notify the responsible people. This information can be used in the schedules for filtering. There can be approval steps, like can we actually deliver the equipment requested? Does it actually make sense, the combination of equipment that was requested? And once fully integrated, the system could even tell you if the equipment that was requested is available in the cruise window. So that's the integration with IMS. Other things that you could do in a proposal is tell what kind of ship-fitted equipment you want to use, or the scientist needs to define the cruise location. So where do you want to do your science? And that is actually cross-referenced against a wide range of different information we have in the database. For example, is it in an EEZ, in a marine protected area? And those data sets we can actually very easily extend. So that's quite useful. Okay, so there we have the proposals. And like I said, they would turn by the programmers into ship schedules. And for the tags interesting, you can view all those schedules in a central place called the program. And that is a place where you can select ships, see on the timeline where they're going to be, the dates. But you can also, for example, filter on equipment usage. So on this particular screen, I showed all the cruises, that's the blue ones highlighted, where the scientists are going to do moorings. You can see the cruise locations on the map. You can click on a cruise to see very detailed information about the sail dates, mobilization dates, but also like descriptions of the cruise, etc. So that's on the program. Other useful information on the program for text might be their own schedule. So like I said, there is a module that can be used to schedule text to cruises, and you can view your own personal schedule on the program. Okay, so that is just a little bit sidetracked what the MFP, like what the other modules can do. If you go to the inventory management, I think there is one sentence that kind of describes what the system is, and that is, the inventory management enables you to know exactly where your equipment is, where it has been, and where it will be in the future, and whether it's fit to use. And that last part is about maintenance and calibrations. So how does that work? So all the inventory is in a equipment overview table. This is a very flexible overview, as in you can tailor this view to your own needs. And it's very easy to disable columns or have your preferred ones shown. And that is tied to your own profile. So if you use the system on a different computer, you will still have your own view. And each column has a set of different filters. So it's very easy to make subsections of your equipment. So we're now looking at equipment that is on the James Cook, that is manufactured by Seabird, for example. And with those cross sections, you can make various reports, like you can do an Excel report, you can view all that in a scheduler, you can have the maintenance expiries, etc. A lot of reporting. Okay, so that is the equipment overview, but for each individual item, we hold a whole range of information. So on the detail page, you see like what kind of type this equipment is. You can see whether it's a generic equipment, meaning you have more than one of them, and you can tie that to different information that the system would pre-fill for you, like the the weight, all kind of things. You basically only have to provide a serial number and some financial data, for example. About the location, so we have two different locations. We have the base location, so where is the equipment expected to be when it's not somewhere else, like its default location. So it could be, for example, a warehouse, it could be a lab, it could be a ship. And the current location is obviously where it is right now, and it could also be on a transport, it could be with a manufacturer for calibration or repairs. It kind of is where it is right now. We come to that later as well. Other information we have is the financial information. When did you bought it? The price of it, the manufacturer, the supplier, etc. We have customs information, like is an export license required? What is the country of origin? The HS code, things like that. The asset management information here can be used to tie this individual item to your asset management system in-house, if you have one. We have the deployment history, which you can use to record kind of usage of this item during cruises. There is the maintenance. After this slide, we'll dive into that. There's document section where you can upload manuals, photos, calibration sheets, certifications, etc. There is the tracking, where you can see where your equipment has been in the past. There is the planning, where it will be in the future. Usage is for another presentation, and you see the content. So in this example, I have a glider. So a glider typically consists of a thruster, of batteries, a science bay, and within that science bay, you would expect sensors. So you can use those locations for each individual item to build systems of equipment. Okay, let's go to maintenance. So on the first screen of the maintenance, you see two types of maintenance. We have a maintenance that derives from a policy, so that's scheduled or planned maintenance, and we identify corrective or unscheduled maintenance. You see both combined in this view, so you have a very good idea of how you service this equipment throughout its life. And if we look about the maintenance policy, so the scheduled equipment, you can have your periodic maintenance. So that is like set on an interval every 6 months, annually, every 2 years. And that would typically be, for example, calibrations or recertifications, things like that. And I think what the MFP or the inventory management here makes different from the industrial standard inventory management systems is that you can also tie that maintenance to actual usage on the cruise. So you can tie it to pre-deployment or pre-cruise usage, for example, a functional test on a winch, or you can attach a checklist for lab containers. And you can also make post-deployment or post-cruise maintenance events. So you say, every time I use this item on a specific cruise, I want to conduct, for example, it could be a recalibration. We have here like the airgun cleaning, surfacing, things like that. So it's quite a flexible system. So how does that look? So if you plan your maintenance, you first create a policy definition. So, what I would like to say here is that you can put a notification in there. So how many days before the expiry of this maintenance event do you want to get notified by the system? You can also tell what kind of maintenance it is and when you want to do it. And you could also provide a detailed job description. You could do that either by uploading a files where kind of, or you can put that description into this form directly. What I would like to emphasize is that maintenance is not a bolt-on functionality, as I might have suggested in the earlier sheet, because we started as a tracking system, but it's a really ingrained part of the system. So on each screen where you look at equipment, we use colorations to notify users when equipment is out of its maintenance windows by showing it in red, or to show that it's about to be out of that maintenance window when it shows in orange. Also, if you create a planning for your equipment, so you say, I want to use this on a cruise in a half year's time, the system can warn you if it's out of date, or even when it's not out of date now, but it will be out of date on the planned usage of that specific item. So it's really ingrained in the system. And another functionality is like, how do you make sure you do all the maintenance on your equipment? You can subscribe to notifications. You can do that for an individual item, or you can also do that for a whole range of equipment by using the selectors, and then bulk subscribe yourself, for example, to all sea containers or to all lab containers, winches. And if you receive a notification, it would look something like what I included here. And you can just click on that reminder, and it will take you directly to that specific maintenance item. Okay. that about maintenance. If we go back to our equipment details screen, you see here the tracking information of a particular item. So you can see it was in the institution, it has been shipped to an agent where it was on a ship, then it has been shipped actually to the to be on the Marcus Lang set, and then it got back from Seattle to Kiel. So it's very detailed. If I would expand one of a note here, I could see who did it, when they did it. And that is one particular item, but I could also make that tracking overview appear for like a range of equipment that I selected. And in this screen, you see both the history as in the planning of the equipment. So this is very easy to help you identify like how many particular items do I have available? Do I have enough to support a cruise, for example? Where have my equipment been? Is it like, do I have too many of the items, or do I need to purchase more? So that is kind of all the equipment basic fields. Like I said, it's a very flexible system. So we could add fields, or if you don't need them, we could remove them from the system as well. Okay, so another thing that we try to do is to not make this a very expert system. So especially for the people not using it on a day-to-day basis, but want to create planning for their cruises, we create something called Plan List. And how does that work? I know I'm on time, so we're going to very quickly. So in the inventory management, as it is part of the whole MFP system, we drag down the cruise schedule. So they're available with all the port calls, all the mobilization dates, etc. in the system. In inventory management, you can create that are the purple lines, kind of your mobilization and demobilization transports, if you want to. And then for the novice users that just want to use the system to create a planning, this is what we call the plan list editor. And it's basically an overview of your equipment. You can add consumables or hazardous materials, and it's a very easy drag and drop system. So you can drag things from the window on the right, which again, you have all the filters that you need, and you can select single items, you can drag multiple items. And that is the only thing you have to do to kind of plan for your mobilizations or for your demobilizations. And you can have multiple people doing that, and then you end up with kind of a mobilization plan as is shown here. So you see there is mobilization in the Walvis Bay in this case. You see the departure. You can see there is a inbound transport coming from Rotterdam. You can see the people that will join the ship on this date. And you can see the various people that created a mobilization planning for this cruise. And this ties back into what I said earlier, like it started out as kind of a track and trace, a customs functionality based system. And what you can do based on all those planning is very easy, create different reports like a pack list, customs reputation, which is actually used by all the users to create valid customs reports that are accepted in all the countries I'm aware of. But you can also create shipping labels, etc. There are numerous reports just based on this very simple plan list principle. So that is kind of in a nutshell what the inventory management is about. What we realized is that a lot of people were screaming for offline functionality, and we had a dedicated scanner functionality, but in the modern times, there was a need for a more modern app. And this app runs on your iPhone, Android phone, but also on your tablet. And the first screen you see here is a MFP is syncing your database. And that is because a subset of data is taken from the central database and is synced onto your mobile phone. And what you can see here is kind of the default view. So you can see script position of ship positions on a map, and you have a lot of different functionality under the main buttons here. Again, you can tailor the appearance of the app. So if you're not interested in any project management related stuff, you can just use the scanner functionality and, for example, view your own personal schedule. And how can you use this offline? So one of the functionalities that we add is the ability to add maintenance offline. So that is quite powerful. So you can, on a ship without internet connection, register scheduled maintenance, but also add corrective maintenance. So if you see, for example, that a sensor is broken, you can just scan that particular sensor and either tell the system that you fixed it on site, so it would be part of your maintenance overview, or you can schedule a maintenance event in the future. So you say, I need to fix this when I'm back home again. I think another powerful feature is that you can attach photos. So if you do this with your tablet or your phone, you can take pictures of, for example, the damage. Another thing that you can do is to track the amount of time that it took you to do a repair. And you can offset that to actually the planned amount of time. So that would help you in the future to better plan your maintenance. Some other things you can do is create your, for example, your demobilization reports offline, to create packing lists offline. A lot of functionality, and this is all synchronized when you have internet connection again. So it could be still on ship or when you're back in the port. I think last thing what I want to show about the app is that you can also use it to register your long-time deployments. So this is long-time deployments are part of our inventory management system as well. And what you can do, there is a mooring module, for example, and you can plan your moorings and then deploy them with their app. But you can also use this, for example, for AUVs or gliders, where you can scan the equipment that you put in the water and also register the recovery again. Okay, so that is the offline app. There is a lot of functionality I could talk about as well, but I'm aware that I'm on the end of my actually over 25 minutes that I had here. I will be around to answer questions on Slack, and I want to thank you for listening then, and thank you, Alice, for the introduction, and happy to answer questions later.
Thank you, Beko. That was great. And there have been several questions in the Slack, so I'm glad to hear you're going to pop in. Yeah, lots of questions. So thank you.
Thank you.
And we are again at our break time. So I think we're going to take a minute. Everybody use the facilities, mute your mic and video, and we'll be back on the hour with Tom Wilson and designing your own PC board.
Hi, Tom. I have your slides.
Excellent.
Maybe I'll just start sharing. Oh.
Okay, we're ready when you are, Lee.
Ready to go?
Tom?
Yep. So our next presentation is by Tom Wilson at Stony Brook University. He'll be presenting on designing your own PC board. And I think Alice has his slides already up.
Okay, thank you, Lee. To paraphrase the 1930s gossip columnist Walter Winchell, good evening or afternoon or morning, depending on your time zone, to everyone from border to border and coast to coast and all the ships at sea. That was the last part. I had to put that in. So you may know the motto of RVTEC, possibly unofficial, is making science work at sea. So while I have the microphone, I wanted to start by taking a moment to thank Brandy and Alice and Lee and everyone else, including all of you out there in Zoom land, who have made RVTEC work over the internet. I think it has worked very well, but here's hoping that in a year or two, we can all flock to one of our partner institutions and meet face-to-face again, even if the after-hours refreshments are more expensive. So, all right, let's go. Next slide, please. All right, so my standard disclaimers. Unless otherwise noted, mention of a company in this presentation does not constitute an official endorsement by SUNY, the State University of New York, or the School of Marine and Atmospheric Sciences, and I have no commercial or ownership interest in any commercial entity mentioned. We also have, click please, the, Alice, click. Oh no, yes, there we go. So we have the special open ocean rated Sea State 6, no chop busting, please disclaimers. Click. That the presenter has never dated anyone connected to any of these companies, nor is that ever likely. And I have not been plied with treats, trinkets, or fancy food and drink. Click, please. And anyone who implies otherwise is asking for trouble. Next slide. Safety, safety, safety. You should always test any designs that you come up with through as wide a range of input conditions as possible. Use appropriate caution with high voltage and high power. Consider redundant dumb limit controls and other safe features. And if you're going to use anything I tell you to build ventilators for COVID, I don't want to know about it. So not for human safety applications. That's a whole different level of ball game. Next. Okay, we'll start off with something that I think can always can be used in so many situations in life and in our thing today. Don't worry, just allergies. Is Gall's law, coined by John Gall, who in fact was a pediatrician. And in learning how things work in hospitals and what doesn't work, he developed a bunch of theories and published a real groundbreaking book in 1975 called Systemantics, How Systems Work and Especially How They Fail. And Gall's first law is that a complex system that works is invariably found to have evolved from a simple system that worked. Next slide. So large and complex, applying that to where we are today, large and complex electronic systems are combinations of smaller and less complex electronic systems. So this has many parallels to programming, where many of us began. So well-designed electronic subsystems are like programming subroutines with defined inputs and outputs, and hopefully sanity checks and safety limits. Next. Next slide. So electronic troubleshooting, which many of us have done, is like code debugging. You work down from the total system to locate the specific subsystem that is malfunctioning. So electronic design is like code writing. You design simple, robust, tested subsystems and then combine them to achieve a large and complex results. The bottom line is, what I'm trying to argue here is if you can learn to write good programs, you can learn to design electronics. Next slide. Next, okay, Gall's Law Part 2. A complex system designed from scratch never works and cannot be patched up to make it work. You have to start over, beginning with a working simple system. And probably any of you who've ever had some big complicated system on the ship go bad, immediately, will know this sort of empirically, because you start disconnecting things until you get down to parts that work, and then you start connecting things back up until things fail, and the last connection you make is probably the system that's the problem. Go ahead, next. Okay, so step one is you want to make an electronic design, and for that I recommend to you UNOLS, the presentation I made at NMARTEC a couple of years ago, and here's the link, so you can go there. So, next slide. Now, I wish I could put in, I was afraid that Condé Nast lawyers might come down on me, so I didn't actually include this New Yorker cartoon from April 2020, but the caption is, "This is it, the time to finish your novel." And the cartoon is hysterical, so I would suggest you Google it and see it yourself. So this is my pandemic novel, something that you all may know. Some of you may know that I've been talking about doing for quite some time, several years. And here I was locked down in Metro New York, the global epicenter of the pandemic. And I said, okay, if I'm ever going to do this, I'm going to do it now. So my novel is the Really Useful Data Logger Board. So the high level specs for that were that it was Arduino based, no single point of failure in the supply chain. I can tell you that for many years, I designed with a particular company's data logger boards that were just the best in the world, and I loved them, and then they decided they weren't going to make them anymore. And it was hard to redesign, but the worst part was that I had stacked feet of code written to work on these systems, and suddenly all of that is you might as well pulp it because you can't use it again. So we're going to have that Arduino based real-time clock, temperature and humidity sensor to monitor the enclosure, SD card data storage, wide input voltage range, plug it into pretty much any kind of power you can get your hands on, battery check circuit, operable from solar power, so not particularly power hungry, multiple RS-232 interfaces, an RS-485 interface with switch sensor power, and then switch power channels for external equipment such as telemetry. And the other thing is that I needed to make this out of 100% out of parts that I could actually get from during the pandemic from DigiKey and from Amazon. And then, of course, there's always budget and there's always deadlines. I had some budget with some projects, and I had to complete this on budget and in time for inclusion in 5 new environmental stations that we're deploying in summer 2020. Next slide. Okay, so here I am, April 2020, in my basement workshop, known to my friends and neighbors as the dungeon. And I was lucky enough, I did take a pano shot of my workbench down there, probably mostly because it's so seldom that you actually can see the work surface. I had it all cleaned up. I said, let's take a picture of this. So I started there, and down at the bottom, you see that I had a proto board, used a good old plug-in proto board, and I got a proof of concept for the novel part of my new design. A lot of those pieces are things that I had done in years past, so I knew how to make them and I knew how to put them together, that they were going to work. All right, go ahead, next slide. So once I have a design, what are my options? So first, you can hand wire, and I don't want you to disrespect hand wiring. It's not a prototype, it's a one-off, and I have done one-offs. The problem with one-offs is that Sometimes you need a second one off, like your buoy gets dragged by ice and the waterproof plugs get pulled out and the entire inside gets flooded. And then maybe you need a third one because somebody thinks it's such a great idea they want one too. So in my experience, the break-even point for designing a PC board versus hand wiring things is somewhere between 2 and 3 boards. Sometimes it's even 2 boards. So it's not that much extra additional effort. And in my experience, it's a good thing to do. So go ahead next. Next. Okay. So a few years ago, 2004, my Lord, I did a presentation at RVTEC on fabricating your own in-house PC boards. And in fact, we've made some, such as these deep sea pump controller timer boards for Challenger deep sea pumps. I will say the time for this is past. Making double-side boards with this is a pain. It takes chemicals, it takes time, it takes a certain level of practice to develop the skill set, and it also, if you're doing it at home, you need to work at odd hours so your spouse or significant other does not see what you're doing in the kitchen sink. That has happened. Lots and lots of newspapers, and the windows are open for the fumes, and you wait until like 11:30 at night. Go ahead. Okay, so which brings us to option 2C, the commercial board house. And wonderfully, over the past 10 or 15 years, there are plenty of manufacturers that sort of cater to the prototyping industry and also to the makers and to the people who are trying to build the next world-beating application out of their garage. So they offer online ordering, low minimums, and quick turnaround. And you get real boards. You get multi-layer boards with plated through holes and a solder mask and silk screen. So today's lesson is building a 2-layer bare board with through-hole components mostly, and using SMT, surface mount components, and boards that are assembled at these board houses. Some of these board houses will also assemble your boards and present them to you ready to plug in, but we'll leave that as an exercise for the student. Next slide. Okay, so you have to start with the design software. The generic term is electronics design automation, or EDA software. And I went with KiCad. I think it's KiCad. It might be KiCad, but anyway, it's KiCad-pcb.org. It's cross-platform. It's open source. It's community supported, and it is free. I love that. Now, the commercial standard is a program called Eagle. It's made by Autodesk, which you may know as the manufacturer of AutoCAD. They have a free version. It's limited to 2 layers, 12 square inches of boards. And if you go beyond that, you get to buy, you can't even buy the software. You have to buy a subscription, which is $60 a month, $495 a year. Now, if you're an engineer at a giant, some giant company, that's no big deal, but $495 a year runs into some money if you're like us and you might do 1 or 2 a year. So the last thing is I tell you to beware of free PCB design tools that are on websites, because they are typically offered by a vendor that trap your files. You can design the board, but then it's there on there. You can only order from that one vendor. And if that vendor rolls over and goes belly up, you're in a lot of trouble if you've put a lot of effort in. Next slide. Okay, so here's a schematic layout, which is guaranteed to impress your supervisor, presuming they said you could actually work on this project. Frankly, this was the easy part. I think I did this in less than 24 hours because I was just putting together pieces that I'd done before through the years. And it looks a little scary, to throw out at you, but remember Gall's Law. Next slide. So this is a complex system made up of 12 simpler systems. So going from top left, there's a RS-485 chip, there's a dual RS-232 chip, there's a battery check circuit, there's a terminal strip, there are 3 power switches with optional voltage regulators. See, that's the trick. You put the power switch in, and then you have the pads for the voltage regulators. If you don't need regulated voltage, you just put a jumper wire in. Then another terminal strip, the input power regulator, RHT sensor and a power switch to turn the RS-232 and 485 driver chips off if you want to save a little power, and the Arduino Mega 2560. Now, not shown, we sort of stack on top of the Arduino an off-the-shelf real-time clock and an SD memory card shield, what they call them now. So that's simple system 13 and 14. But any one of those systems, I mean, if you guys got one of these things and we're trying to troubleshoot it out at sea, that's not any more complicated than a lot of things that we work on. So it is, you can break it down and understand it. Go ahead. All right, so each component on the schematic includes a designator, you know, U4 or Q3 or R9, an identification of what the chip is or the value of a component, and if appropriate, their pin definitions, and those just come in when you go into the schematic design. You'll say, oh, find me a 555 find me a 555 timer chip, and it just comes up, and all these lovely things and the pinouts and everything are there. So you select components from the standard libraries, and you can define your own, but there are particularly these community sorted, developed libraries. There are tens of thousands. I think the only component I had to define on my design was a touch point. Next slide. All right, now this is the next thing you have to do. After you got your schematic finished, you have to assign footprints, because a 10K resistor, is that a 10K 5-watt resistor, or is that a 10K surface mount chip resistor? So you again, there are footprints. You can define your own footprints, or you just look through tens of thousands of components and you find the footprint for your device. And the footprint can be very simple, like down on the lower left, you see it's just a plain old quarter-watt resistor, through hole, axial, laid down on the board. So there it is. And then on the right, bottom right, is the shield, the pinout for the Arduino Mega. So you can get a footprint that's simple, you can get a footprint that's complex, and there are plenty of people out there who are designing footprints. You can take one that's there and you can say, gee, I want a pad a little bit bigger or something like that. You can make modifications and save it as your own. Go ahead. All right, now, here comes the part where people might like stand up and walk away. So you have to generate from the schematic, you generate something called the net list. Now, the net list is a file, text file, that lists all the components, the associated physical footprints, because that's also the pinouts, and all the interconnections. You know, this wire from V plus goes to this regulator, goes to this chip, goes to this chip, goes to this chip, okay? So you have to export the net list and save your schematic. You have been doing that, haven't you? And exit the schematic editor, and you're feeling good. You printed it out, it looks lovely. Now you have to start the PC board, physical PC board editor. You take a deep breath, you intone to yourself, fear is the mind killer. I'm looking forward to that movie next year, by the way. And you import the net list. Go ahead. This is the rat nest. Okay, next slide. So what happens is the PC board editor starts by just jamming all the components that are in your schematic onto the board, and then draws those little white lines, in this particular case, 127 little white lines between all the pads that need to be connected. So you have to figure out, in this case, where to place 69 components and then how to route 127 traces between them. Yes, some PC board software will purport to auto place and auto route. Those with the money to buy those high-end packages, I do have some friends in the commercial world with essentially unlimited budgets, tell me none of them work very well. And so take heart. This is something that human beings can still do better than computers can. Next slide. Okay, so to lay out the board, you put on some groovy music. Don't ask me why, but 2 decades ago, I learned that putting on Parliament Funkadelic works for me. You know, it's just like, it gets you in the groove and you start running. So if you have a board size constraint, you draw the lines that are called edge cuts. Otherwise, leave that to the end, because you might find that the edge of your board needs to shift a 1/4 inch, or you need another 1/4 inch somewhere. So if you have components that have to go somewhere, such as buttons, displays, or terminal strips, you place them first. Then you start grouping related components together, and then you start routing traces. Now, if two traces have to cross, you can go from top to bottom to top on a component pad, for example, or you can add what's called a via, which is just like this little tiny pad with essentially no hole, just a teeny little hole for the plate through. And that allows you to jump. So you go up and down. But of course, the fewer jumps from top to bottom you have, the better off. Go ahead. Now, layout tips. I like wide traces. I like lots of spacing. That's probably left over from those days when I was doing desktop PC boards, and that way a board that didn't develop real well was still usable. So supposedly the program will not let you inadvertently short two nets together. Remember the net list? So it won't let you connect things that shouldn't be connected. Now, if you can't not make a trace, if you can't connect a trace that you know needs to be there, that probably means there's an error in the net list. So you go back to the schematic, double check it. If you made an error, go back and correct it, generate a new net list, and then you can update the net list. You don't have to start over again. You can sort of update the net list on your PC board. So obviously you save a lot, you save new versions a lot. So if you mess up, you can back up, not start over. So every successful trace you put in lowers, if you look all the way down at the bottom, it says unrouted. In this case, it's unrouted 70. So every successful trace lowers the unrouted count towards that magical number of 0 unrouted. Go ahead. And eventually you have reached Nirvana version 1.00, where there are 0 unrouted traces and you have this glorious looking board. And you can see the two different colors, red's the top and green's the bottom. And there, you can click on the thing to show only the top, only the bottom, only the silk screen. You can also see in blue that there's cute little silk screen things that actually label what everything is. So it's a real board. Go ahead. So now you export manufacturing files, and here's where I, was of course pushing deadlines, and I made the mistake of leaving the default, which was use extended X2 format. And when I sent the board files into the largest PC board manufacturer, one of the largest PC board manufacturers in the United States, it blew up on me. Oh, manufacturing errors, and we ended up having to import. Like I imported the files and then exported them, and then they took them. And then when I realized with some experimentation that this extended X2 format is not recognized by all manufacturers. So do the old-fashioned way and don't do that. All right, next. So now here's the manufacturing files list. So the ones that are for this particular logger. So the ones that are GBR is called a Gerber photo plot format. Okay, so you can see that there are Gerber files for the front copper, the back copper, the board edges, the solder mask front and back, and the silk screens front and back. Then the .drl are the drill files. So that shows the thing. It shows the XY positions to drill holes through the board. And then the NPTH is non-plated through holes, like where you're putting a screw, mounting screw or something like that. And then PTH is plated through holes. And then there's a file called .gbrjob, and I'm not sure what it does, but it didn't matter. You just take all of those and you just put them in a zip file. Go ahead. And then you send them off to a board place. Now, I use 4PCB.com because they have worked for me. But if you use 4PCB.com, I strongly suggest that you send your zip file to their file check site for free design for manufacturability. And you get a report back, usually in less than 2 hours, and it says, you know, this looks fine. I always get complaints that my silkscreen, my silkscreen line widths are too narrow, so they may not print very well, and I've always ignored those. One day I may try to fix that, but it'll say this board can be manufactured, this board can't be manufactured, this is what we would have trouble with if we actually tried to make them, and that's just worth its weight in gold. So do that first. Next. Then you send it to manufacturing. And again, this is the same Advanced Circuits company in Arizona. You upload and place the order. I have been buying their $33 board special because I'm doing small quantities. Their minimum order quantity for that is 3. So for $100, you get 3 boards back, 2-layer silkscreen, solder masked, plated, through holes, 3-day turnaround, and then they ship it out to you. So that's a deal. Usually, unless you're making more than 15 or 20 boards, you know, $33 is cheaper. If you're going to make 50 boards, you get a quote and you get them to make it. But usually, if you get multiple boards, you know, other than this special, it's usually going to be $400 or $500 for the first board, and then the ones after that are $3 a piece or something like that. Go ahead. So in a week or so, boards, you get them, you know, you open the package up and there they are. And it's just what you had planned on. And to my amazement, the first time I got these overnighted, and I opened the box up and realized that I just paid overnight freight on a free package of microwave popcorn. But after that, it was still nice. You get free microwave popcorn on top of every board order you get. Next. So then you assemble a board. Here's one of those boards assembled and ready to rock. Remember, I told it was mostly through hole. I do cheat. If you look over in the upper right-hand corner, you'll see there's a surface mount component plus an SMC to dip adapter board. You know, this happened to be a RS-485 driver chip that I couldn't get in dip, but I could get in a surface mount, and I could buy a carrier board. So you search for those boards. They're available for lots of different types of surface mount components. And in fact, there are companies like SparkFun or Adafruit who do that already, you know, for people who are doing prototyping, you know, breadboarding and prototyping. So like, for example, at the bottom on right, you see Adafruit does this breakout board for a 4-channel 16-bit A to D converter with programmable gain amplifier in the front. Gotta love that. That's actually on my next version of this board. Next. So we program and test it. After all, we just built the hardware. Now we got to make the software work. So here it is. Another one of my workbenches in the dungeon. Amazingly, you can see the surface, the burned and pitted and marked and stained surface. But on the left, from the left to the right, is a 4G router that we use for telemetry, a serial to Ethernet IP converter, and the data logger board, and an RS-485 pressure sensor. And I will tell you, in previous RVTECs, I've talked about the thrill or the pain, the agony of making RS-485 work. When you have your own RS-485 chip and you actually have a microcontroller that can control the chip, I have come, as Steve Martin you once said, the secret to RS-485 is like the secret of comedy. It's to timing. So if you can control your chip, you control the transmit to receive, the listen times, the trick to making RS-485 work is having the right timing, knowing how long to talk, how long to wait, how long to listen for. Go ahead. And then we deploy. Here it is in the real world. You can see in summer 2020, we deployed 2 TAD stations using those pressure sensors, 485 communicating pressure sensors, 2 salinity stations using RBR salinity instruments, and 1 multi-parameter floating platform that had a ton of things on it. So the little board, my really useful little board, is telemeters the process data, but it also has 8 gigabytes of flash memory on it, which basically was the smallest card that I could buy easily and cheaply. And it allows local storage of not only the process data, so you can pull it back, or if you lose telemetry, you can pull the data at some later time, but it also allows local storage of every single instrument scan. The tag gauges take 120 pressure readings to a second for 60 seconds. And I think I figured it would hold 15 years of scans, an 8 gigabyte card. And if I run low, I just put a 64 gigabyte card in it. So you can reprocess or you can troubleshoot with that. And in fact, we had a pressure sensor fail on one of the tag gauges, and I was able from the raw data to see that was the problem rather than a communications problem. So it was allowed me to do troubleshooting before I even went out to the site. So it's working great. We're expecting to upgrade 6 existing data stations with these boards in the next 6 months. Go ahead. And of course, that was version 1.00, but there's always a punch list. So I actually have already ordered and received version 1.01. So I found there was an orphan via, and there was a trace to nowhere, and there was one digital line that was on the wrong digital pin because I was very careful, but I didn't know that the SD card used a digital line 10, so I had to move that trace. And of course, we all know about making makeup wires, so you cut the trace on 1.00 and route it to a different digital pin, and 1.01 fixes that. And then I had 2 terminal strips that were both numbered 1 to 12, and that doesn't make sense. So we renumbered terminal strip number 2 to 13 to 24. And next version 1.1 is going to have a more accurate real-time clock. The one that we picked has a little bit more drift than I'm happy with. And we're going to add that 4-channel 16-bit A to D. Next. And I have to acknowledge all the people that I work with that are part of the team that make things happen around here. A tip of the hat to Forrest Mims, who was actually talked about more in my electronics design presentation, but one of the guys who got me into electronics design, wonderful author who knows how to make simple systems that work. To my parents, who always, as a child, always found a few dollars to invest in my education and trips to Halley Electronics in my little hometown of West Virginia, or Radio Shack, or the Pagoda Hardware Store, and to the long-suffering employees of those 3 institutions who would always see me coming through the door, and they would say, "What are you going to do with XYZ?" And I say, "I'm building something." And of course, that gave them no help. And then, of course, to teachers, mentors, students, and colleagues, including Henry Harrison, David Lusick, Bob Slavonic, and across the bottom, I've got a few pictures. Trevor Young, some of you know, now at Hawaii. Greg Smith, who's now at the Naval Research Lab in Maryland, suburban Maryland. Alex, who was my right-hand man for many years here, has now started a new job protecting our nation, working for Boeing Underwater Systems Corporation, and I feel safer already. Chris Crosby is now at Rutgers, and my current one of my current colleagues, Miles Litzman, standing proudly by one of those telemetry stations we just put in. And of course, all of you at RVTEC. I've learned so much here, and thank you all for that. Next slide. So if there are any questions, I am not afraid.
This is such a great presentation, Tom. Thank you. We have some questions in the Slack, and I'm going to give you the option. Would you like me to read them to you, or would you like to read and answer?
Let me see if I can get to, I actually have the Slack sort of up. Let's see if I can get to it. PC boards. Yeah, okay, let's see. Just to write, we do not endorse creating boards in spaces used for preparing food. Yes, well, at this point, I don't endorse creating boards at all. We order boards, but yes. Contact cleaner, surface mount soldering. I can't even see most of the parts. Yes, I was able to do with, if you got it takes a certain touch, but yes, I can get I can do surface mount soldering and did on that little 8-pin flat pack dip. So let's see. Fritzing, designing PC boards. Yes, there are other options out there. Fritzing as a PC board design tool, I've heard of them. I went with, I did go with KiCad, and I am happy. The bottom line is they're all tools, and whatever tool works for you is just fine. They all, I presume they all generate the standard, industry standard manufacturing files. So, you're cool. Let's see. Seed Studio, yes. I have seen some places from China, 10 boards for $4.90. They're in China. You'll still spend more in shipping than for the boards, right? And that is about it. So next slide, final slide. So thank you all very much. You know where to find me. I challenge you to now go build stuff. I am going to go have some microwave popcorn.
Thank you, Tom. That was great. And it looks like an eventful summer.
Yes, thank you.
That is technically the end of our presentations for the official RVTEC sessions. Is there anything that we want to say or do or reminders before we wrap up?
Should we confirm how the logistics are going to work for the session tomorrow?
Tomorrow, yeah, that's a good idea. Does John Haverlack? Oh no, he's not on here.
He's not on the.
Randy,
on
you
the
know.
Zoom. So I have sent John an email of everybody who has registered. He sent an email earlier, and the instructions are in the Slack, the admin mesh network Slack, with virtual box downloads, I believe. So there's a little bit of homework ahead of time. But other than that, I think all of the information can be found in the Slack.
Yep.
Yeah.
And is that via Zoom and YouTube?
It's not going to be streamed on YouTube,
Yep,
mostly
okay.
because it's interactive and live questions. So it's all going to be in the
obvious.
Zoom. And people who have registered should have already received a link. If I'm going to send a reminder to all the registrants today, so that should be good to go, unless there's some last minute registrants. John says I'm correct, so.
Yep.
I guess I would like to say that in this world of Zoom, which I think we're going to be in for a little while longer, if there are other topics that the techs out there want to hear about or discuss, we can set up more Zoom meetings and record them for others to hear. So I don't know, someone had mentioned talking about dredging and other topics. So if there are things you want to bring up, let us know, and we can work with that, find experts in those topics and start a conversation. So let's make the most of this sort of time, right?
Toby also reminded me the UHDAS social yesterday went so well, they're going to do it again today, same time. So there will be a Zoom link in the Open Social channel as well. If you couldn't make the other ones, it'd be fun to make this one. So as we mentioned previously, the end date of the Slack is not yet determined, and we don't expect that most participants have been able to watch these live. So if you have questions, please still put them in the Slack channels, and hopefully our presenters will keep checking them for a little while and get you answered. If you haven't registered or attended our VTech because you were busy or you weren't sure how it was going to go, let me know, and we can still get you in the Slack before it disappears so you can catch up on what you've missed. And the presentations will remain public and live on the UNOL's YouTube channel. I think I covered most of them. Jim, would you like to say goodbye to your techs?
I'm just gobstruck. I can't believe what a great group. I mean, y'all should all pat yourselves on the back. We got a really good group here, and I just shake my head and says, wow, that was really good. So well done. I think we're in hands. Carry on, because you know we are the highest life form as technicians.
Thanks, Jim.
Yeah. And for those of you who have, some of the introduction slides have come in late. And if you haven't looked at it since you submitted one, I recommend going in and check out some of your fellow technicians. Again, I don't know how long that one's going to survive either. So get in and check everybody out. And there are email addresses in there so you can contact one another. If you can find them in the Slack, you can chat with them there too. So thank you.
Yes, thank you. Thank you, everyone, all the presenters, and spending time answering questions in Slack. We really appreciate making this as interactive as possible, given the circumstances. So thanks again.
Oh, bye for now.
Yeah, I did send an email to the managers. Typically at RVTEC, we have a managers meeting while everybody is live. I'll send a doodle very shortly about getting the managers together for a catch up, but it's not this week.
Sounds good.
Thank you.
Okay.